Okay, so this is one of the final methods for solving a system that we're going to look at. This is called the elimination method. Usually, elimination method works best if you have equations that are not in slope-intercept form, and they're not solved for a variable, so they wouldn't work well with substitution unless you did some work first. These ones are set up so the x's and the y, first comes the x's, y, then equal to something, is like general form. It's general form for a linear equation. What we're going to do here is we're actually going to be doing some vertical math, and the idea here is to try to cancel out one of the variables. Either cancel out the x or cancel out the y. This first example is the example because it's already set up for us very nicely. If I were to go ahead and just go right into adding these together, combining 2x with 3x would give me 5x. Combining positive 5 and negative 5y, they cancel each other out. 24 plus 11 is 35. This left me with a very nice, tidy equation. If I divide both sides by 5, I have an x value of 7. Because I can't just give the x value, which is going to be 7, I need to go ahead and plug 7 in for x to one of the original equations and find my y. So if I use the first one, 2 times 7 plus 5y equals 24. That's here. 14 plus 5y equals 24. Subtract 14 from both sides. 5y equals 10. Divide both sides by 5. Y is going to be equal to 2. Pretty cool. I wish all of them were that nice and tidy, but they usually require a little bit more work. For instance, if I was going to start off with this next one and go right into adding them together, I wouldn't cancel anything out. But I can notice here that I could have it a little bit easier. This is the thing, like you don't always necessarily cancel for x or cancel for y. You get to pick which situation you want to use depending on what you're given. In this case, I'm looking at 3x and 5x. I could cancel them out, but I would have to do a lot of work. I'm looking here at negative 8y. In order to cancel out a negative 8y, I would need to combine it with a positive 8y. And I have a positive 2y here. So what I'm going to have to do is I'm going to have to rewrite this whole top equation. And I'm going to multiply the entire equation by the number that would turn this into a positive 8y. The only thing is I have to do this to each and every piece in order for this to remain true to being equal to what it started off with. So 4 times 3x is 12x. 4 times 2y is 8y. 4 times 10 is 40. My second equation, I'm just going to keep it the way it was and bring it down. Then I'm going to go ahead and combine things. I have 17x, my y is canceled, equals 68. If I divide by 17, this is going to give me, I believe, 4. Yep, definitely. X equals 4. And I'm going to go ahead and I'm going to take one of my original equations, plug 4 in for x. So I have 20 minus 8y equals 28. Subtract 20 from both sides. Negative 8y equals 8. And then divide both sides by negative 8 to get a y value of negative 1. So x is 4. Y is negative 1. I found my solution to this system. Had to do a little bit of manipulating, and that's always fun, but that's a thing. I also put down here at the end the formal explanation for how to use the elimination method to solve a system of equations. So that's the steps kind of written down for you if you need to look at them slowly or just go over them a couple more times. Maybe it's explained a little better. But let's go to the next page. Okay, so we have another example. Solve the following system of linear equations by elimination. Notice this time we don't have x's and y's, we have g's and h's, and that's okay. You can pick which one you want to try to cancel out, G's or H. I'm kind of thinking G's because 3 and 6 kind of have common factors. I could very easily cancel out a positive 6G if I have a negative 3G, which I can only get if I multiply that whole top row by negative 2. Notice that I'm changing not only the numbers, but I'm changing the symbols and manipulating by changing the symbols to get what I want. So negative 2 times 3G is negative 6G. Negative 2 times 5H is negative 10H. Negative 2 times 27 is negative 54. I'm going to bring down my original second equation so that I have everything lined up. Nice, tidy, vertical combining situation. The G's cancel out. I have negative 3H. If I were to combine negative 54 with a positive 39, that would give me negative 15. And then I'm going to go ahead and divide both sides by negative 3. And H is going to be equal to 5. I can put 5 in for H. I'm assuming that this ordered pair starts with a lower number first, so 5 goes here. I'm going to go ahead and write down one of my original equations and substitute 5 in for H so that I can figure out what G is. Subtract 25 from both sides. 3G equals 2. Divide both sides by 3. Yes, this is possible. My G value is 2/3. And that can happen. It has happened, and it's not the worst thing. I know some people, if they got that, they would think they did something wrong. But nothing's done wrong. Looks beautiful. Why don't you take a moment and do this next example. Pause the video, get as far as you can get, come back and see if you did it the way that I would have done it, or close. Okay, so I'm looking at this and I'm thinking the logical thing here would be to cancel out my x's. I can do that if I multiply my whole top row by 3. Positive 3x would cancel out with a negative 3x. So when I rewrite the top row, it's 3x plus 24y equals negative 105. And then I'm going to rewrite my original second equation underneath. So my x's cancel. I end up with 29y and negative 116. Divide both sides by 29. And then when I put that in the calculator, negative 116 divided by 25 is negative 4. Now that I have my y value, I'm going to go ahead and plug that in. I'm just going to pick one of those equations. X minus 32 equals 35. Let's put the negative symbol there. I was looking for what I did wrong. Add 32 to both sides. X equals negative 3. I always forget negatives sometimes, so I always have to kind of keep an eye on what I'm doing so I don't do things absentmindedly. The answer to this one, ordered pair, negative 3, comma, negative 4. I want you to pause the video and do A and do B. And then when you come back, I am just going to have the answers displayed. You can check it now. You can sit here and wait and not do anything, but then you're robbing yourself of learning how to do this, and I wouldn't do that. So I'm going to go ahead and pause the video and do the next 2 examples, and then come back. So both of these ended up being challenging. For A, I decided to start off by multiplying the entire second equation by 2. That brought me down here. When I combined these together, I ended up with a fraction, 2/3. I anticipated that it was going to be kind of rough for me to plug in 2/3 for P and solve for W. So what I did is I actually wrote these out again, and then I multiplied both sides to make it so that my P's are canceling out so I could cancel for W. So I multiplied the top by 4 in the bottom row by 5 and created a whole nother system that I was solving by elimination so I could solve for W, which is kind of cool. So I went through all of the motions to solve for P and then all the motions to solve for W. That's a thing you can do. For B, I multiplied the entire top row by 4 so I could cancel x's. What ended up happening is I was able to cancel everything. So infinite many solutions, all real numbers are the solutions. That's a thing that can happen. Okay. Jim Johnson is a local vet who has prescribed a diet of 24% protein for a client's Great Dane. And Jim has 2 types of dog food shown below, but neither is 25% protein. So he wants 225 pounds of food to feed the Great Dane until the next appointment. How much should he combine to make it so that this is 24%? I'm going to call this bag A. I'm going to call this bag B. I'm also going to call this 0.24, and I'm going to call this, let's see here, oh, yep, this is 0.21, this is 0.30. Things I know. If A is going to be pounds of the first part and B is pounds of the second bag, and I add up how much I need altogether, 225 pounds is how many we need together. It says if you add up all the pounds, it should be 225. I also know that a percentage of this protein in A is going to be 0.21. The percentage of protein for B is 0.30. And by the time we're done, we want 225 pounds of 0.24%. We have built ourselves a system. So is it tricky? Yes. Is it a pain? Nah, maybe. But I'm going to show you really quickly what I'm going to do. I'm actually going to put both of these in Desmos. And instead of using A and B, I'm going to use X and Y because I don't think Desmos is going to recognize A and B, and that's okay. So go ahead and take a minute. I want you to put this in the first row, put this one in the second row in Desmos to see what you get. So I went ahead and I put this in Desmos, and I'm going to add the picture now. Here it is. Notice that I used X and Y instead of A and B, and I put these in to Desmos, and I tapped to find what the solution is. The solution is 150, 75. If we interpret that in terms of the problem, the context of the problem, that would mean that we need 150 pounds of A, bag A, which is 21%, and 75 pounds of 30% in order to have 225 pounds of 24%. Lots of stuff. Okay, I think this is the last page for this one. I will be back in the next video.